Okay, Assalamualaikum. Okay, so today's lecture is about the lack of fit test. If you can remember, before this, we check for the linearity of the regression function and using the correlation ataupun using the scatter plot, we can see that our regression function is fit to the data or not. Okay, so before this, we use the scatter plot to check for the fit of the data, and actually, it is another way to confirm that our regression function fit to the data or not, which is using the lack of fit test. Okay, so before this, let's say yang ni kan, saya just tunjuk contoh yang sama yang sebelum ni. Okay, this is the uh, correlation plot, okay, which is the scatter diagram of y versus x. Okay, the scatter plot of y versus x. Okay, so from the scatter plot, we have the scatter plot when we um, plot the value of y and x in a graph, kan? So kita akan dapat the scatter diagram here. Okay, and then when we fitted the regression line, we have the when we estimate the parameter of beta naught and beta 1, we can have the regression function, okay, ataupun the regression line that we can draw in this the same graph, okay, the same graph dengan scatter diagram dekat sini. So daripada situ kita boleh tengok whether our regression line yang kita dapat tadi when we estimate the beta naught and beta 1, we have the regression function. When we draw the regression line here, okay, from that, we can see whether our plot ataupun our regression line tadi fit the point yang kita ada. Okay, so kita boleh tengok whether most of the point berada dekat dengan fitted line or not. Kalau dengan pandangan mata kasar, kita boleh tengoklah whether we can conclude that the regression line is fit or not for the data. Okay, but some of the individu have the different um, apa different um, apa ni conclusion about the regression line dan juga scatter diagram. So because of that, we have another method to confirm that our regression line is fit or not using the lack of fit test. Okay, we go back here. Okay. Okay, so kita kat sini, we illustrate this test for uncertain, for ascertaining whether a linear regression function is a good fit for the data or not. Okay, so dia punya assumption, the lack of fit assume that the observation y for given x are independent. So we need to check dulu the observation y for given x, our data tadi, are independent and normally distributed, and the distribution have the same variance of sigma squared. Okay, so kena check dulu assumption of the regression. Independent, normal dan juga same variance. Then we can proceed with the lack of fit test. Because of if one of these assumption is not fulfilled, so no point. So we can conclude that the regression, we cannot proceed with the regression analysis. So no need for us to check for the lack of fit. So let's see how we conduct the lack of fit test. Jadi kata kat sini, the lack of fit test require repeat observation at one or more x levels. Okay, so in simple linear regression analysis, we have one y and we have one x. So kena check dulu X untuk conduct this leg of fit test, kena check level of X tu must be repeat. Ada replication for the value of X. Okay. Let's see the example. In this example, experiment involving 12 similar but scattered suburban branch office of a commercial bank. Okay. Minimum initial deposit in the new money market account was specified to qualify for the gift. The value of the gift was directly proportional to the specified minimum deposit. Various level of the minimum deposit and related gift values were used in the experiment in order to ascertain the relation between the specified minimum deposit and the gift value. Okay, so altogether we have 6 levels of minimum deposit and the proportional gift value were used with 2 of the branch office assigned at random to each level. Okay, so let's see the data here. Di dalam your textbook, you boleh check you boleh tengok your textbook, page 120. Okay, so this is the data. We have 11 here. We have 11 data. Okay, we have 11 branch here. And then, okay, so we have column X and column Y. What we need to concern is, kena tengok dekat value of X column. Okay, ada tak repeated value of X? Okay, so from here, we can see that we have 2125, we have 200, we have 200, we have 275. So, ada value X yang repeated. So, we can proceed with the lack of fit test. Okay, so, okay, ini and okay, alright. Okay, so we have this data. And then if we conduct the um, OLS method, and then we have the value of beta naught and beta 1. So we will have this regression function ataupun regression line. So kita nak check whether this regression function is fit for the data or not. So because of that, kita nak buat lack of fit test ni. Okay. So bila kita regress, dah dapatlah ini ANOVA table, ada SSE, ada SSR, ada SST, ada degree of freedom, and ada juga mean square. The value of mean square. Okay, so this is the scatter plot of Y versus X here. And then ini yang kita dapat, dia punya scatter plot. Ini scatter plot yang dapat. And then this is the regression line. Ini. Bila kita draw the regression line in the same graph, so ini yang kita dapat. So dengan pandangan mata kasar, kita boleh tengok sebenarnya this regression function fit the data very well or not. So daripada sini kita boleh tengok yang ianya ada quadratic kan, macam quadratic pattern. So kita katakan the regression line ni not fit the data very well. But to confirm that, kita kena buat lack of fit test. Sebab some of the data dia tak nampak obvious macam ni. So untuk confirmkan the result ataupun the decision whether the regression line fit the data or not, so kita kena buat this test. Okay. So first of all, you need to arrange. Okay, kena arrange dulu data X tadi kan. We have the replication of X. So kena arrange dulu mengikut X. So X tadi kita ada 6 level. 75, 100, 125, 150, 175 and 200. So kena arrange dulu the data. Okay, kena arrange dulu. And then bring together the Y. Ini value Y. 2842. Okay, boleh tengok balik dekat page 120 tadi. Okay, bila kita ambil 75 value X, value Y nya 28 and 42. So, kena arrange dulu this X, okay, and bring together dia punya Y. Okay, itu the first step, kena arrange X dulu. Okay, put together the replicate X. Okay, bring along the Y. Okay, the next step, kita kena kira Y bar ni. Kena kira Y bar, kenapa? Kejap lagi dalam formula of SSPE akan ada value of Y bar. Okay, Y bar ni adalah value for Y bar for each replicate X tadi. Sebab tu kita kena arrange X tadi. Okay, bring along the Y. So, Y bar ni adalah mean of the the Y for each replicate X. Okay, so how to get 35 here? 28 plus 42 divided by 2. Mean kan? Kena bahagi dengan 2. If we have 3 replication here, so kena tambah 3 bahagi 3 lah untuk dapatkan Y bar here. So each of these semuanya ada replicate with 2 replication. So semuanya divide by 2 lah. So here 124. How to get this? 112 plus 136 divided by 2. Okay, and then kalau you tengok dekat replicate 150, only one replication here. So dia punya Y bar is the value of that Y lah, which is 152 divided by 1, right? Okay, so when we have this Y bar, okay, I tunjukkan cara macam mana nak buat test. Bila nak buat test ni, means that kena ada hypothesis testing lah. Ni kena ada H0, H1. Okay, so this is dia punya hypothesis. H0, as beta of Y equal to beta 0 plus beta 1X, which is kat sini kita boleh tulis juga dia sebagai boleh juga tulis macam tu ataupun boleh tulis as the regression line. Okay, the regression line ataupun regression function is linear. H0. Okay, untuk H1, the regression function is not linear. Okay, ataupun satu lagi kita boleh tulis as there is no lack of fit. Maksudnya, the regression line fit the data well. Okay, there is no lack of fit. H1, there is a lack of fit. So, apa yang kita nak kat sini, kita nak fail to reach H0 lah in order to use our regression function that we have. Okay, so that is H0 and H1. Okay, and then the test statistic adalah this. Sebenarnya this one. Okay, the test statistic adalah SSE minus SSE reduced minus SSE full divide dengan degree of freedom for reduced minus degree of freedom for the full model bahagi dengan SSEF over DF untuk full model. Ataupun kita boleh tulis dia sebagai SSE minus SSPE. Okay, how to get this? SSE adalah macam biasalah, SSE reduce ni ada SSE untuk model. Okay, adalah SSE untuk model. Okay, SSE reduce adalah SSE untuk model because of we have this. So, macam mana dapatkan SSE? Macam sebelum ni lah. We have the formula yang you have learned before this. Whether you boleh guna formula ataupun if you also can use the matrix approach. Okay, it depends pada situation. Okay, itu SSE. How to get the SSPE? Okay, SSPE adalah degree of freedom, degree of freedom to SSE macam biasalah, it is n minus 2. Okay, so macam mana dapatkan SSPE? So this is the formula to get the SSPE. Atau SSPE ni ataupun SS full adalah SSPE, which is this is the formula. Summation of Yij minus Y bar J. Ni Y bar yang kita cari tadi untuk mean for every replicate tadi kan? Mean of Y for every replicate. So kenapa kita guna Y bar tu? sebab SSE untuk full ini dipanggil full model. So kat sini mu plus epsilon. So mu di sini adalah y bar. Mu di sini adalah y bar. So untuk dapatkan SSE untuk full model, okay, SSE untuk full model which is yij minus y bar j square. Okay. So which mean di sini tadi contoh kita contoh tadi kan, di sini yj, di sini y bar, di sini setiap ni adalah y kan, value of y untuk for every replicate. So apa yang you kena cari, nak cari SSPE. Okay, the formula is summation of yij is all this value minus dengan y bar j square. Y bar untuk every replicate tadi. So means that the first one will be 28 minus kyi minus dengan x y bar which is 35 square plus okay 42, the next one untuk replicate 75 first minus 35 square. Okay, and then plus tengok pula yang replicate yang kedua, dia punya yi adalah 11 yij 112 minus dengan y bar j which is 124. Okay, so you should do this for each of the yij minus x y bar j for every value of y ni square. Okay, you should total up that, you akan dapat the value of SPE. Okay, so here. Okay, so you akan dapat 1148 SSPE. Okay, the degree of freedom for SSPE adalah n minus Cn adalah number of observation, C adalah component. Berapa tadi number of replication? Okay, berapa level of replication tadi? Component kita ada X yang replicate tadi ada 6 kan? X yang replicate, so C here will be 6. Okay, let's see again here. Okay, so here SSE minus SSPE over n minus 2 which is the degree of freedom for SSE minus n minus C which is the degree of freedom for SSPE. So this actually SSE minus SSPE ni adalah dipanggil SS log, SS lack of free ataupun SSLF ataupun SS log pun boleh, which is SSE minus SSPE. Okay, this part adalah SS log. Degree of freedom untuk SS log adalah, bila kita tolak dua ni lah, dia punya degree of freedom SS log will be, it will be C minus, right? It is C minus. Okay, so bila SS log divide its degree of freedom bahagi SSPE divide its degree of freedom, ini dipanggil MS log over MSPE. Okay, how to get MS log? This SS log divide its degree of freedom C minus 2 bahagi MSPE SSPE over its degree of freedom. Itu dia punya test statistik when we want to test for the lack of freedom, which is this. Ini adalah test statistik MS log over MSPE. You should know how to get the degree of freedom for SS log dan SSPE. Okay, so we will reject hash note if, okay, ini reject hash note. Biasa kan kita akan tengok yang reject hash note. Ambil satu pun tak apa, dua-dua pun boleh. So kita akan reject hash note bila F statistic more than the value of F table. Okay, I repeat again here, 1 minus alpha dekat sini sebab dalam textbook, your textbook table dekat belakang, ianya table less than. Tapi kalau guna table merah, ianya table more than. So kat sini F alpha sahaja. Okay. C minus 2, N minus C, sebab C minus 2 ni adalah degree of freedom untuk SS law, dan N minus C ada degree of freedom untuk SS PE. Okay, so we will reject hash note if the F statistic more than the F table. So bila reject hash note, we can say that our the regression line is not linear, ataupun the regression function there is a lack of fit. Kalau kita reject hash note, there is a lack of fit. So maksudnya the regression line does not fit the data well. Okay, if reject hash note. Okay. So daripada sini, okay, ini example yang atas tadi. Okay, so of course lah kena ada value of, kena ada test statistik, kena ada hash note, hash 1 first. Okay, and then determine your value of alpha berapa, and then barulah cari F statistic, which is MS PE, MS log divide dengan MS PE. So macam mana dapat degree of freedom of MS log is 4, which is C minus 2. C adalah number of component of X that replicate, which is 6 tadi, ada 6 level of X yang replicate. Okay, X ada 6 level. So we have N minus, C minus 2 here will be 4. And then degree of freedom for MSPE adalah N minus C, which is 11 number of observation, minus dengan 6, which is ada 6 component. Ada 6 level of X. Okay, which is 5. So when we divided these two, we'll get 14.8. And then comparekan dengan F table. Kat sini dapat 11.4. So because of F statistic more than the F table, critical value from the F table, so we fail to reject hash note. We reject hash note. We conclude hash 1. Okay, we reject hash note because of F more than value of F table. So the regression function is not linear, ataupun boleh juga katakan there is a lack of fit. Then the regression function is not fit the data very well. Okay, that is the conclusion that can you make. Okay, let's see another example. This example. Okay, the following data shows the retail price for 12 randomly selected laptop computers along with their corresponding processor speed. Okay, so the speed of the processor adalah X, the price will be the Y. Okay, so here perform the F test to determine whether or not there is a lack of fit for a linear regression function kita nak test. Okay, the lack of fit, gunakan F test. Okay, so we have this X. So you kena tengok level of X, ada tak yang replicate level of X. So we have this 2, ada 2, ada 3 tu. Okay, ada 4, the speednya 2.0. 1.6 pun ada yang replicate. So we can do this test. Okay, so first of all, like I said just now, kena arrange dulu the level of X together with the Y. Kena arrange X yang replicate. So kat sini 1.6, 1.6, 2. 1.6 dan 2 yang replicate. So we have 6 level of X here. 1, 2, 3, 4, 5, 6. Okay. And this is bring along the value of Y. And then dapatkan Y bar in order to find the value of SSPE after this. So Y bar yang tak replicate ni, so Y bar ni still the same lah. 1, 2, 4, 9 here. 1, 3, 4, 9 here. 1196. Kat sini how I get 1791.7. 1229 plus 1419 plus 1849 plus 2669. Okay, divide by 4 sebab I ambil mean. So, dapatlah 1791.6. You can double check. The same value. Okay, yang ni pun sama. I get the mean of this 4 value. So, dapat 281.5. Okay, so to find the SSPE, as we know, the formula of SSPE is double summation of yi minus y bar j square. So, this kena this one, this column minus dengan this column square kan untuk dapatkan value of SSPE. So, each of that you need to calculate manually. Kena buat satu-satu. So, for each yang tak replicate ni, value-nya 0 lah. Right? Di sini saja yang you kena kira. Okay, so it will be 1229 minus 1791.5 dan square kan. You akan dapat the first one 316,406.25. Kolom ni tak perlu buat pun tak apa. 316,406.25 untuk yang the first one. Second one buat pula 1419 minus 1791.5 dan square you akan dapat 138,756.25 and then the next one 1849 minus 1791.5 dan square you akan dapat 3306.25 and then kena buatlah sekali tu 2669 minus 1791.5 dan square you akan dapat 770006.25. Kat sini 0. Kat sini pun kena buat satu, kena ada 4 value. Then you total up this, you akan dapat value of SSPE. Okay. Untuk dapat value SSPE, which is actually the value-nya adalah 125,8350. Okay, nanti check. Okay, untuk dapatkan SSE, untuk dapat SSE, kena, kalau ada ANOVA table, so terus boleh ambil daripada ANOVA table. If not, you kena calculate using the formula. Guna formula ni boleh, guna formula sebelum ni pun boleh, nak guna matrix approach pun boleh, tak ada masalah. So, in order to get this, you have to find all the summation value kan untuk dapatkan SYY, it is summation of y square minus summation of y, all of that square divided by n. Dapatkan SXY, summation XY minus summation X multiplied summation Y divided by n. Kan? So, kena kira that value first untuk dapatkan value of SSE. So, berapa kat sini value of SSE that we can calculate. I calculate that. SXY square. Okay, divide dengan SYY. Sorry, divide dengan SXX. And then SYY minus that value. So you will get here SSE 185,6400. Okay. So once we have the SSE, sebab apa kita kira? Sebab nak cari SS loss. Jadi SSE minus SSPE. So you akan dapat 125,8350. You akan dapat SS loss-nya adalah 598,050. Okay, so we have SSPE, we have SS loss. So we need to find the MSPE dan MS loss in order to find the test statistic. So MSPE adalah SSPE divide dengan degree of freedom. How to get 6 here? Degree of freedom untuk MSPE adalah apa dia tadi? It is C minus 2, right? So C minus 2 untuk SS law, which is we have C adalah number of component ataupun level of X. We have 6 tadi. 6 minus 2 will get 4. So 598 050 divide by 4, you akan dapat 149,512.5 divide dengan MSPE, SSPE divide dengan N minus C. How to get this 6? N minus C, berapa tadi? 12 kan? 12 observation minus dengan level, we have 6 level of X. So 12 minus 6, we will get 6. So it is 209,725. When we divided that value, so lastly we get 0.7129. You can put 3 or 4 decimal places, meaningful decimal places. Okay, so we need to put the as hypothesis. So you boleh tulis macam ni, ataupun boleh tulis whether the regression model is linear or not, or boleh juga tulis there is no lack of fit or there is lack of fit. Okay, so that F statistic tadi salah ni, bukan 3. The value tadi adalah 0.7129. So and then compare it with the critical value from the F table. F 0.05 if we use the alpha of 0.0546 ni adalah degree of freedom for SS law and degree of freedom untuk SSPE. So to check your table merah, you akan dapat 4.53. Since the value of S statistic less than the critical value, so we fail to reject hash not. Okay, I nak kita sini tak boleh kita accept. Kita sepatutnya tulis we fail to reject. Okay, we fail to reject hash not. So means that we conclude hash not, which is the regression model is linear ataupun there is no lack of fit. Then we can say that the regression function is fit the data very well. Yeah? So that is the way how you conduct the lack of fit test. Right? So actually you have learned also this method in diploma level, but maybe some of you dah lupa, so you need to refresh back. Okay, so it will evaluate in your exam.